So this next part, okay, is the last portion of binomial. Okay. So there's this thing called the general term, or we call TR plus 1. Okay, it's a bit similar to when y'all do number patterns. Okay, we call the general term Tn. Okay, but in this case it's called TR plus 1. Okay, it goes to this expression here. So this one is given in the formula sheet. Okay, don't need to memorize. Okay, but of course, if you can, it'll be good to memorize. Okay. Okay, so when do I use this general term or this formula here is when, okay, I don't want to go through the tedious work of expanding to find particular terms. Okay, what do I mean by this? Okay, so for example, okay, in this expansion here first. Okay, not say the expansion, sorry, this term here. Okay, where is the power 12. Okay, I don't want you to expand. If I ask you to find the fifth term, okay, fifth term means T5. Alright, T5. So which means R plus 1 will be equals to 5. Okay, R will be equals to 4. So essentially to find term 5, okay, or T5, you sub in your R as 4. Okay, so over here, identifying your A, B, and N is what we've been doing from the very start. Okay, when we do the expansions. Okay, so 12 bracket 4, or 12 choose 4. Okay, bracket because it's N minus R in the formula. So 2x squared bracket N, which is 12, minus R, which is 4. Okay, same thing, you do the same thing for B as well. So key out these values in the calculator individually first. Okay, so I will get 495. Okay, from the 12 choose 4. Okay, 2x squared, this one is 12 minus 4 is 8, right? So 2 to the power of 8, you get 256. Okay, x squared to the power of 8. Power of power, you multiply, you get x power 16. Okay, this one over here, since the power here is positive, which means my negative will be gone. Okay, so I'll get 1 over 81 x power 4. Okay, so now again, deal with the coefficient first. So my coefficient will be 495 times 256 times 1 over 81. Okay, key this in a calculator, you should get 1564, 4 over 9. Okay, a mixed fraction. The x power, okay, it will be x power 16 times 1 over x to the power of 4. Okay, basically the power of x, okay, 16 minus 4. You will get x to the power of 12. Okay, so if you find it hard to do it at one shot, you do it individually. Work with the number first or the coefficient first, followed by the x power. Okay, can? Okay, so if for example you are asked to find the middle term for n equals to 12. Okay, if my n equals to 12, there will be 13 terms. So the middle term will just be T7. Okay, essentially, or to find the middle term, you take number of terms plus 1 over 2. Okay, can? Okay, next. Earlier is I'll ask you to find a particular term number, okay, which means term 5, term 4, term 6, etc. What if within the expansion, I want you to find a particular term that has a certain x power? So in this portion, when you see term independent of x means I don't have an x term, which means my power of x is 0. Okay, my power of x is 0. Okay, because anything to the power of 0 is 1. Okay, so now you have to apply the TR plus 1. So let's do an example below here. Okay, again, I'm using the same binomial expansion here. Okay, but I want you to find the term independent of x. So term independent of x, again, it just means I want to find a constant. Okay, where the x power is 0. So identify your A, B, and N. Okay, same as earlier. Okay, so put it into the TR plus 1 formula first. So TR plus 1 equals to this expression here. So because I'm looking at term independent of x, okay, highlight this. I'm only interested in the portions where there's x powers. Okay, nothing else. Meaning to say, okay, in this expansion formula here, the only portion which will affect my x power, okay, is this portion here and this portion here. Anything else, I'm not interested in. Okay, so the x power that I'll get from this term here, okay, is just x squared bracket 12 minus r. Okay, because again, laws of indices, power you multiply. The second portion here, please take note. Okay, I emphasize again, I'm only interested in the terms that affect x power. So the negative, I don't care. Okay, the 1 over 3, I'm also not interested. So it's just 1 over x to the power of r. Okay, and then what do I equate it to? Because I want to find term independent of x, I equate it to x power 0. Okay, I equate it to x power 0. From there, okay, I combine these two fractions. Okay, or simply put, okay, I can jump straight. If you are familiar with the laws of indices, this will become x to the power of 24 minus 2r times, okay, 1 over x will become x to the power minus 1. Okay, so this will actually become what? Okay, times in indices is plus, right? So basically, you plus a negative number is still minus, so minus r. Okay, this is how I get this form here. Okay, and then equate it. Okay, this is your indices. same base, I can equate the powers. Alright, so 24 minus 2r minus r equals to 0. Okay, so this portion you all have to be familiar with the laws of indices. If not, you all cannot catch what I'm saying. So after that, what you do is you solve for r. Okay, in the event where you solve for r and it's not a whole number, which means most probably you have some careless mistake or you apply the formula wrongly, because r must be a whole number and it must be positive. Okay, if I get a fraction or a decimal or a negative number for r, which means it is wrong. Okay, so solve for r, I got r equals to 8. Now you put r equals to 8 back into the tr plus 1 formula here. So essentially I can directly say when I use r as the value of 8, I will get the term independent of x, or in other words I can say I'm getting the term with x power 0. Okay, so I just throw in the value of r as 8. Okay, key in the calculator, and then okay, for this particular portion here, normally I ask you all to work out the number first, then x power. But in this case, there's no need to work out x power because I know for this value of r that I'm putting, I already know that the x power is going to be 0. So for this particular expansion here, all you need to work out is just the coefficient. Okay, or in this case the constant, because it's the term independent of x. Okay, can then leave your final answer in mixed fraction, that's all. Okay, so now that we have looked at that, okay, let's look at another example. Okay, exact same concept, just that I'm asking you to look for a different term now. So if I ask you to find the coefficient of 1 over x cubed in this, essentially it's another way of saying let's look for the terms with x cubed first. Oh, sorry, 1 over x cubed. So again, what I want you all to always start off by writing is the tr plus 1 first. Okay, so let's write tr plus 1 equals to, okay, in this case my n is 12 already, so 12 choose r. Okay, 3x to the power of 12 minus r, and then I have minus 2 over x squared, okay, to the power of r. So again, focus on, okay, what you need to solve for is the r value to sub back in to get the coefficient of 1 over x cubed. So focus on the terms, or the x terms that will affect your x power, which is this portion here, and this portion here. Okay, so again, I'm gonna write, okay, so x to the power of 12 minus r, okay, bracket, multiply. Take note, the x squared term here is in the bottom. Okay, so essentially this here is 1 over x squared to the power of r, and I equate it to 1 over x cubed. Okay, so when I equate the powers, or when I simplify the powers, let's simplify the powers first. So this becomes x12 minus r. Okay, over here when I bring it up, it will become minus 2. Okay, so when I bring it up, it will become minus 3. So essentially when I equate the powers, this is what you will get. 12 minus r minus 2r equals to minus 3. Okay, and from there solve for r, you should get r equals to 5. Okay, since it's a whole number, you know you've done it right. Okay, so next, okay, you're right. Okay, since my r is 5, essentially what I'm working out is the 6th term, right? Okay, or instead of writing a 6th term, let's write, okay, term with x cubed, or 1 over x cubed, sorry. Okay, so I'll sub back in the value of 5. Okay, immediately, again, I emphasize there's no need to work out the x power because I already know what is the x power I'm going to get with this r value. So immediately, I'm going to put x to the power of minus 3 here. Okay? Or you can put it like that. Just put over x cubed first. Okay? So the remaining portion is you just key in the calculator the coefficient. Okay, which is in the calculator, this is what you should key. 12 choose 5 times 3 to the power of 12 minus 5, 7 times minus 2 to the power of 5. Okay, and then you'll get this number here, which is quite a huge number. Okay, so write a final statement, therefore, coefficient of 1 over x cubed will equals to the value here. That's all. Okay, can? So this is how you apply your general term or your tr plus 1. And then the last part is the show type, or the show portion for this type of concept using tr plus 1. Okay, so since this is the hence portion, for the same binomial expansion. Okay, essentially to show that there's no coefficient of x power 5, okay, what I need to do? You need to show that r is not an integer. Okay, meaning to say when I equate the x power to solve for r, okay, when I equate it to x power 5 and I solve for r, if you all realize subsequently behind, okay, equating the power, solve for r is not an integer, it means the x power 5 term does not exist. So similarly, if I ask you to prove that a certain term exists, you just need to prove to me for that certain r value or the x power value, r is a integer. Okay? And so this is the basic type of question or the standard questions that you all will see, where you all need to use your tr plus 1 general term.